Hi, the goal of this short video is to show you how to use and run long polling demo application written to my article on mrmatrix.net. To start debugging application, you should just run two projects at once. So select on the solution properties and select multiple project startup. When you are ready, you can just start run application. When you run application, you'll see three windows. The first one is the long polling server, so the main concept presented here. You can recognize this because it listens on the port 5286 on localhost, and you can see that already one consumer is connected. The second application is demo, is a .NET client, which one is used just to demo how to connect to this long polling server and take the events from it using the single connection. The third one is a web application. I mean the SPA exactly application, which one allows us to better debug the solution. You can see that there is also a link to the Swagger, and if you click the Swagger, you will see that there are exposed four endpoints, let's say, four endpoints with two methods. The getter methods as used to long polling. Unfortunately, Swagger do not allow you to test this long polling process, so this is why I do not recommend use it here. Just use the web application. And the second one are append endpoints, just to send events to the long polling server, so to trigger some actions on the client side. To help with debugging, I've also added a small REST HTTP client. You can run it from the Visual Studio Code, just to append around 100 messages to show how the application works. So let's start from the demo and then we will analyze the code. So the first thing is that when you start synchronize on the long polling web customer, you will see that when you press the synchronize button, here new customer connected is logged on the server side. Now, when you send, for example, single message, we can do this from the Swagger, why not? So from the Swagger, we just append single event. So let's call it test one, why not? And when we send this event, it's automatically sent to our .NET friend. And as you can see, because I started the synchronization process, it's also presented here. But as I mentioned in the blog, the connection is still opened, so we are sending any JSON back to our customer sites. So when I send the request, as you can see here, 100 events were sent here, and they automatically on the same HTTP connection. So there was no connection recreated. They automatically appeared here. And of course, if I've append, for example, 5,000 messages here, they are shown here as well. I mean, they are sent to the server and they return to us via this long polling connection. So events sent to us from the server side. And we can see here that also .NET application work fine. What you can notice here that when I'm appending 5,000 messages, they are appeared almost instantly here, but in the .NET application it takes a while. And the case here is that it's the problem with the logger. I mean, the logger just logs slower messages than they arrived, and this is also why it slows down the process. Okay, so we saw how to use the application. Of course, if I abort the connection, so now when I close the connection, I can see that consumer disconnected. I'm not receiving any new messages here. Of course, if I synchronize with the sequence, global sequence number 10,201, it's just reinitiate from the next event. So as you can see, I'm already on 301 suffix. So that's how it works. Now when we saw how the application works, let's analyze the code. So as you can see, application contains few files, so it's really simple to implement long polling process. There is single controller. I will show you soon how it works. There is an event, which one we are going to emit. And this ND-JSON output formatter is just to add new line after each object sent from the controller. So now when we saw how it is structurized, let's see what is going on. So let's start from the events controller. Event controller, to synchronize all consumers, uses task completion source. But of course, as you know, you can complete task only once. So this is why we are using a trick here. So let's start from getters for a moment to see how it's organized. So when someone asks us to get the set of messages, set of events, the controller just returns async enumerable and checks the global sequence number. What you can see here, let's move to the top, the payloads are stored in synchronized collection. So synchronized collection just guarantees that we are safely atomically add the new elements to the collection. So this is why we are using it. And of course, if we are not ready, we should just stop. So what we are doing here, let's skip this part. This is the only trick to just avoid some kind of timeout on the .NET clients. So what we are doing, we are just taking the global sequence number from our consumer, and we are checking here if the payload count, so if consumer already consumed the last sequence number. If not, we are just need to wait. And we could when we check this, we could just wait here on the task, so task completion source dot task wait async. But there is a small risk of race condition. I'm not going to go too deep here, but that's why first I'm taking the task from the task completion source, then I'm checking if I'm above the limit, so I should just if I'm below the limit, so if I should wait, or if I'm above the limit, just take the new payload from the payloads collection. So this is exactly why I'm doing this here. So I'm waiting for the task completion source only if I'm already consumed everything what was waiting, and if the task completion source returns a task which one is completed, then I can move on and recheck if I'm below or I should just start consuming the messages. As you can see, I'm using async enumerable to emit each payload, so I'm just returning in this infinite loop. But as I mentioned, task completion source can be completed only once. So now let's move to the append part. And let's focus on the single append. So what we are doing here in the append, we are just adding the payload. So by default in this blocking collection, the counter will be increased. And then we trigger task completion. What does it mean trigger task completion? So what we are doing here, we are just creating new task completion source first, then we safely atomically exchange the existing task completion source static variable with our new task completion source. As a result, we are receiving here automatically the previous instance stored in the static member, and then we are just completing received task completion source. By doing this, we are just releasing all pending threads waiting on this current task completion source. So what we are doing here, we are exchanging each time task completion source with new value. And that's all. Now, of course, to emit events, by default, unfortunately, the default serializer in ASP.NET will return only the full JSON payload, but we are planning here to return application X-ended JSON. So to do this, we need to add our custom formatter. So what is going on here? Each time when this method returns a value, we have dedicated NDJSON output formatter, which one expects that when the payload appears here, so for each, we are awaiting it as well, so for each payload coming from the controller, we are just sending back serialized single object, and we are adding a new line. Yeah. So this is what is going on here. And that's the whole idea behind the server. So by just applying this few, maybe 200 lines of code, maybe 100 lines of code, you can just prepare your own long polling server to deliver that part for your customers, which one, for example, cannot expose any port outside their infrastructure at the moment. I hope this short video helped you to understand the code. Thank you.